Lesson number 6, Reflection and Refraction. By the end of this lesson, you should be able to describe what is meant by refraction. When light hits a wall or another flat object, it bounces off at the same angle. This is reflection, and it allows us to see objects which do not produce their own light. We see the reflected rays which enter our eyes. The diagram shows light striking a flat surface. The angle at which the ray meets the surface, the angle of incidence, is the same as the angle at which it leaves the surface, the angle of reflection. This is the law of reflection. The dashed line drawn at 90 degrees to the surface is called the normal. Angles are always measured from the normal and not from the surface. When light passes from one transparent medium to another, for example from air into glass, some light is reflected and some passes through. As the light passes into the second material, it changes speed and direction. When a wave experiences a change in direction due to a change in speed, this is refraction. Light travels in glass at 2/3 of the speed it travels in air. If light rays enter the new medium along the normal, they change speed but do not change direction. If light strikes the boundary at an angle, there is a change of both speed and direction. When going from glass to air, the light rays speed up and refract away from the normal. When going from air to glass, the rays slow down and refract towards the normal. When light arrives at a boundary between two materials, the light can be both reflected and refracted, or all of it can be reflected. It depends on the angle of incidence. If light moves from a denser material such as water to a less dense material such as air, most light is refracted away from the normal, but some light is reflected. If the angle of incidence increases to a certain angle, called the critical angle, then all the light is refracted at 90 degrees to the normal, along the boundary. If the angle of incidence is above the critical angle, then all of the light is reflected, staying inside the denser material. This is called total internal reflection.